Hello friends, in this video I will tell you about different types of metal forming processes. So the first process is shearing force. In the shearing force we can solve the example by taking F is equal to STL as a formula. So on the screen we can see that F is equal to STL. F is the shearing force and capital S is the shearing strength. T is thickness of the component and L is length of the component. So the shearing strength will be taken as 0.7 into ultimate tensile strength as given on the screen. So the next one is bending force. In the bending force we have formula F is equal to KBF, ultimate tensile strength, into width into thickness square upon length. So in this formula we have ultimate tensile strength, we have W is equal to width in mm, thickness also come in mm, L means length in mm, and KBF is the bending factor. So the bending factor for V bending we can take KBF is equal to 1.33. For edge bending we can take KBF is equal to 0.5U. So the next process is drawing process. So the formula will be capital F is equal to pi into T into dP into ultimate tensile strength in bracket dr minus 0.7. So T means thickness, dP means punch diameter, UTS means ultimate tensile strength, and dr is the ratio of dP upon dB. So in this formula shear strength also can be calculated by S is equal to 0.7 into ultimate tensile strength, and dV means blank diameter and T means thickness. So the next process is extrusion process. So extrusion processes we can have the following formulas. RE means reduction ratio, which can be calculated by AI upon AO is equal to DI upon DO bracket square. Epsilon is equal to ln of RE. Ln means natural log and epsilon means true strain. Sigma F average is the average flow stress, which can be given as K into epsilon raised to n upon n plus 1. So sigma F average is equal to K. K means constant and epsilon means true strain raised to n. N means the flow index. Capital P represent the pressure, applied pressure. Capital P can be calculated as average flow stress into epsilon. If the friction condition is given in the example, we can take capital P is equal to sigma F average in bracket epsilon x minus twice L upon dl. So the epsilon x is the extrusion strain, and which can be calculated by epsilon x is equal to 0.8 plus 1.5 into ln of RE. So after all this calculation, the final result will be found out by the force required for the extrusion process. So for the force we can have F is equal to P into pi by 4 into di square. So in the gate examination the examples comes in the form of that calculate force required for extrusion process. So by these steps or using these formulas we can calculate extrusion force. So the next process is rolling process. So in this we have L is equal to under root R into delta T. Delta T is the reduction in the thickness of the component after rolling and before rolling. So delta T is also can be calculated by mu square into R. Mu is the coefficient of friction and R is the radius of the particular rolling section. Also we can find bite angle alpha So for that we have cos alpha is equal to 1 minus delta t upon d, and also it can be calculated by direct formula 1 minus 0.5 into mu square. So by using these formulas we can calculate delta t and alpha. So the next will be epsilon. True strain is equal to ln of ti upon to, and the average flow of stress is equal to k epsilon n epsilon raised to n upon n plus 1. And the force can be calculated by sigma f average into length into width, and the torque also be calculated by T is equal to force into length. So on the left hand side we have brief information about all the formulas used. So for the first, reduction means delta T, radius means delta R, initial thickness will be Ti, final thickness will be To, true strain is equal to epsilon, average mean flow stress is equal to sigma f average, and the length L and width W, force of the extrusion which is F. So forging process, for forging process we have epsilon is equal to ln initial height upon final height, which is given by initial height is hi and final height is ho. Sigma f is the flow stress which can be given by k into epsilon raised to n. Sf is the shape factor. Sf is equal to 1 plus 0.4 into mu into d upon h. Mu is again the coefficient of friction, d is the diameter of the forge, the component should be forged, and h is the final height of the component. So the force which is always asked in the examination, in the GATE examination for the forging process. So F is equal to SF into AO into sigma F. SF is the shape factor, AO is final area, sigma F is the flow stress, and AI into HI is equal to AO into HO. By using this formula we can calculate AO, which is required for calculation of force. So on the left hand side we have shape factor SF, coefficient of friction mu, area which is given by AI and AO, initial height HI, final height HO, true strain epsilon, average mean flow stress sigma F, and force of extrusion which is given by capital F.